Phase 1. Phase 1 to 03. The bottom aeration system creates massive water bubbles, vigorously churning the tamarind pods. Phase 1. Phase 1-04. Close-up of tiny ozone bubbles clinging to the pods. Phase 1. The pods continuously tumble and lightly collide with each other. Phase 1. Phase 1 through 09. The tamarind pods pass through rotating soft brush rollers that gently scrub the shell. Phase 1. Phase 1 through 10. Small twigs, leaves, or floating debris are automatically pushed into a discharge channel. Phase 1. Phase 1 through 11. Crystal clear surface rinse water is sprayed one last time to ensure no residual impurities. Phase 1. Phase 1 through 14. The powerful airflow forcefully blows away the remaining water droplets.
Phase 1. Phase 1 to 15. The central control panel displays the water flow rate and ozone concentration. Phase 1. Phase 1 to 16. The completely clean and dry tamarind pods move smoothly towards the next stage.
Phase 2. Phase 2-26. The inner tamarind pulp gradually turns a glossy, dark brown, becoming softer and more pliable. Phase 2. Phase 2-27. The blanching cycle ends, and the automatic pressure relief valve hisses, venting excess steam. Phase 2. Phase 2-30. The tamarind moves along a long cooling conveyor, equipped with powerful fans. Phase 2. Phase 2-32. The softened tamarind continuously drops into the feed hopper of the mechanical deshelling system. Phase 3. Phase 3-34. The friction and pressure from the rotating rollers violently crush the softened outer shells. Phase 3. Phase 3-36. A powerful horizontal air blower system cuts across the falling crushed pods. Phase 3. Phase 3-37. The light, dry shell fragments are blown away by the air current, completely separating.
Phase 3. Phase 3-39. The raw tamarind pulp is collected at the bottom of the chute.
Phase 3. Phase 3-45. The monitoring screen displays a 98% successful deshelling rate, indicating stable operation. Phase 3. Phase 3-46. The continuous stream of wet tamarind pulp slides down a smooth, polished chute. Phase 3. Phase 3-47. A rotating roller at the end of the chute gently pushes the pulp down. Phase 3. Phase 3-48. The sticky pulp, seeds included, pours heavily into the feed hopper of the centrifuge. Phase 4. Phase 4-49. The dark pulp mass is sucked into the cylindrical extruder for seed separation. Phase 4. Phase 4-51. The pressure from the screw forces the material against a thick, perforated cylinder. Phase 4. Phase 4-54. The central centrifugal shaft starts spinning at high speed, completely wringing the pulp. Phase 4. Phase 4-55. Extreme centrifugal force flings the core seeds towards the waste discharge port. Phase 4. Phase 4-56. Close-up of the smooth, black seeds rattling out of the waste chute. Phase 4. Phase 4-57. External scraper blades wipe away the raw tamarind paste clinging to the outside. Phase 4. Phase 4-58. The raw tamarind paste flows thickly and sluggishly down the inner walls. Phase 4. Phase 4-59. The rejected seeds fall continuously into a large bin, later transferred out. Phase 4. Phase 4-61. The centrifuge control panel blinks green, signaling optimal RPM efficiency. Phase 4. Phase 4-63. The intense vibration breaks down any remaining large, clumpy masses of pulp. Phase 4. Phase 4-64. The raw paste is forcefully sucked by a heavy-duty gear pump. Phase 5. Phase 5-66. The paste is injected into a multi-layer vibrating sieve for filtration. Phase 5. Phase 5-69. The second layer filters out tiny sand particles or microscopic shell fragments. Phase 5. Phase 5-70. Close-up of the accumulated tamarind fibers on the mesh being pushed. Phase 5. Phase 5-71. The paste passes through the final ultrafine micron sieve, becoming incredibly smooth. Phase 5. Phase 5-73. A worker inspects the waste discharge chute to ensure fibers are extracted. Phase 5. Phase 5-74. An automatic water spray system periodically cleans the filtration mesh. Phase 5. Phase 5-75. The pressure gauge on the piping system displays stable pump pressure. Phase 5. Phase 5-79. The solenoid valve at the bottom of the intermediate tank opens. Phase 5. Phase 5-80. A screw pump gently draws the puree and pushes it directly into the tower. Phase 6. Phase 6-82. Close up through the transparent sight glass, showing the paste boiling vigorously. Phase 6, Phase 6-86. The vapor passes through a condenser, cooling and liquefying into water.
Phase 6, Phase 6-87. Inside the tank, rotating scraper blades continuously sweep the walls. Phase 6, Phase 6-92. The central HMI screen draws a real-time graph showing the brick's content.
Phase 6, Phase 6-93. A technician peers through the sight glass, nodding to visually confirm quality. Phase 6, Phase 6-94. The vacuum pump stops, and a pressure compensation valve releases air.
Phase 6, Phase 6-96. The heavy paste is strongly suctioned by a specialized gear pump.
Phase 7, Phase 7-98. The massive anchor agitator inside the tank starts rotating slowly, folding the paste.
Phase 7, Phase 7-99. Close-up of the thick paste rolling into large waves inside the tank.
Phase 7, Phase 7-103. An automatic dosing pump injects a precise, tiny amount of purified water. Phase 7, Phase 7-104. High-speed disperser blades spin furiously to completely break down clumps.
Phase 7, Phase 7-105. Close-up of the paste being torn and blended by the toothed blades.
Phase 7, Phase 7-107. Close-up using a stainless steel spoon to scoop the paste high up.
Phase 7, Phase 7-108. The system screen logs that the batch is completely homogenized.
Phase 7, Phase 7-110. The tank's heating jacket circulates warm water to maintain the paste temperature.
Phase 7, Phase 7-1111. The indicator light on the homogenization tank changes from yellow to green.
Phase 7, Phase 7-113. A specialized lobe pump gently pushes the thick paste toward the sterilizer.
Phase 8,
Phase 8-114. The concentrated paste is forced through the steel cores of the heat exchanger. Phase 8, Phase 8-115. Superheated steam in the outer jacket forces the temperature to skyrocket. Phase 8, Phase 8-117. The flowing paste maintains this ultra-high temperature for a precise duration. Phase 8, Phase 8-120. The continuous swirling flow inside the tube ensures thorough sterilization.
Phase 8. Phase 8-122. Spores and spoilage microorganisms are completely destroyed in the process. Phase 8. Phase 8-123. A flow sensor accurately measures the mass of paste passing per minute.
Phase 8. Phase 8-124. If the temperature drops below standard, the flow diversion valve instantly opens. Phase 8. Phase 8-125. Close-up of a spring-loaded valve aggressively diverting the flow. Phase 8. Phase 8-126. A green light indicates the paste flow is 100% sterilized. Phase 8. Phase 8-127. The UHT piping is covered in thick insulation to protect operators. Phase 8. Phase 8-129. The paste finishes its lightning-fast heat cycle, perfectly maintaining natural flavor.
Phase 9. Phase 9-130. Instantly, the hot paste floods into the cooling jacket section.
Phase 9. Phase 9-131. Cold water runs continuously in the outer jacket, absorbing the heat.
Phase 9. Phase 9-134. A thin layer of frost condenses on the outside of the pipe. Phase 9. Phase 9-135. The cooled, thick paste slowly glides along the stainless pipe.
Phase 9. Phase 9-136. The pipeline pierces through the insulated panel wall to the packaging room.
Phase 9. Phase 9-137. The cool paste pours smoothly into a massive stainless steel aseptic tank.
Phase 9. Phase 9-138. The air supply to the aseptic tank passes through a HEPA filter. Phase 9. Phase 9-142. The Teflon membrane aseptic valve at the tank's bottom is clamped.
Phase 9. Phase 9-143. Blue UV sterilization lights illuminate the piping connecting the holding tank. Phase 10. Phase 10-146. An automated jar unscrambler places rows of empty, pre-sterilized glass jars.
Phase 10. Phase 10-148. Optical sensors count the jars and clamp them securely on the conveyor. Phase 10. Phase 10-150. Dosing pistons push powerfully, and the thick, glossy paste erupts.
Phase 10. Phase 10-152. The paste perfectly fills the jar right up to the designated line.
Phase 10. Phase 10-153. The filling nozzles cut off the flow flawlessly thanks to a drawback valve. Phase 10. Phase 10-154. The nozzle rack shoots upward, and the conveyor slides the jars forward. Phase 10. Phase 10-156. A nitrogen purging machine injects a light stream into the headspace.
Phase 10. Phase 10-157. Close-up of the white vapor of nitrogen gas cascading over the rim.
Phase 10. Phase 10-158. An AI camera scans the rim of every freshly filled jar. Phase 10, Phase 10-161. Close-up of the paste surface remaining completely still inside the jar.
Phase 10, Phase 10-162. A red light indicates the filling cluster is running smoothly at speed.
Phase 11, Phase 11-163. The conveyor guides the filled jars beneath an overhead foil applicator.
Phase 11, Phase 11-165. The loosely foiled jars pass through a tunnel with magnetic induction.
Phase 11, Phase 11-167. Close-up of the flat, perfectly sealed aluminum foil entirely covering the paste.